Yep, so welcome everyone to the 2020 APAC Groundbreakers Virtual Tour by APAC OUC. And this year, our event would be the biggest one ever done, with 174 sessions that would be including normal sessions, workshops, and hands-on labs from 120 different speakers over 11 days. Also, it would cover sessions on 4 different languages, so please remember to register to as many sessions as you can, and all sessions would be available to replay as many times as you want for 2 weeks after the initial session date and time. You can also interact with the speaker at any time during that 2 weeks by posting questions or comments directly in the playback session page. Now I would like to say thanks to all Oracle user groups and Java user groups that made this event possible, and also to our cloud sponsors, Oracle Groundbreakers and CloudDB. Now for today's session, REST, gRPC, GraphQL, What API tech should I be using? By Phil Wilkins. Please feel free to write questions at any time during the session at the Q&A tab of the Zoom webinar, and the speaker would be answering them at the end of the session. If any issues during the presentation, please feel free to contact me at any time on the chat tab of the Zoom webinar. Now, without any more delays, I would like to leave you with this amazing session by Phil. Take it away, Phil.
Thank you. Right, share my screen. Hey, so, excuse me, right. Yes, gRPC, GraphQL, and REST. Let's get cracking. So, just introduce myself very quickly. I'm a husband, father, a blogger, and an author in a number of areas, including integration and APIs. And I work for Capgemini here in the UK as part of an award-winning team. Don't need to really record anything more than my website address because most of the material here in one shape or another is already online and available. So don't worry about trying to capture notes and things like that. It's all available. And of course, there's the recordings. So beyond that, I run a developer meetup in London with Oracle, and in these days of COVID, that's all online. So you know, watch out for that. And we federated that with quite a few other meetups, so it gets streamed quite widely. As I say, I've written a fair few books and articles and magazine journals. And here are the big ones that I've contributed to. So, you know, if it's of interest, go have a look. As Capgemini, I'm not going to say too much more about that. Before I talk about, you know, the different API technologies, it's worth looking a little bit at of background and how things have evolved to get to where we are today, because there's some interesting themes there that have a background influence on the guidance that we ultimately conclude with. So integration in the widest sense and APIs started out, you know, pretty much when we started writing software, where we were doing APIs and sharing between applications data, and it used to be, you know, file transfers, so just an agreed file structure and a file being moved around. And we moved into databases of various forms, and therefore you could share a database table, and obviously the data definition would be the definition of the interface. And then again, as things moved on, we went into network file shares, again back towards files and the simplicity that provides and the human readability, and very flexible. And then as we moved on, we suddenly jumped into the world of networked based in integration technologies and APIs. And we saw COM and DCOM come along in the Microsoft space. Corba got itself pretty well established for quite a long time. And if you're a Java developer, you'll know all about RMI. And as we moved into the millennium, we then saw XML RPC come along, and then REST and SOAP. Ironically, actually, REST was defined in a different way to SOAP in terms of approach to describing what it is, but we saw SOAP take off, and now REST is the more dominant of the two these days. And most recently, we've seen Avro, for those that are into Kafka-based integration. gRPCs is certainly arrived, and it is more of a network technology layer. And then GraphQL, which comes back to more the XML human readable dimension of integration and interfacing through APIs. But yeah, while some of these are on the decline, they're still kicking around. We still use databases even today as a means of APIs in the broader sense. So it was worth, I thought, when this subject came up quite a few times as a result of conversations with clients, to explore a little bit about adoption and how much impact. And you can see from this graph, this is from Google Trends, the adoption pattern. So both GraphQL and gRPC are being picked up, but GraphQL is by far the more dominant, possibly because it's the easier to get to grips with and has a number of easier routes into use. But they're both picking up steadily, making an impression. But if we compare that to REST, they're still in the minority today. And if anybody tries to claim that they're going to be a giant killer in terms of disposing of REST, this graph kind of begs to differ. We've seen a little bit of drop in REST adoption, but that drop is nowhere near as representative of the growth in other technologies. I think the reality is we are seeing and will continue to see just a simple growth of API adoption, and we'll see REST here to stay, but we'll see more GraphQL and gRPC coming along. So it's worth looking at the underlying principles and ideas that sit behind the different technologies and their strengths and weaknesses before we look at the underlying question of which technology to use. So let's start with REST. This is the best known of the three. It was originally actually described in a white paper by a guy called Roy Fielding, and he called out 6 to 8 themes, depending on whose publication and interpretation of Roy's papers. You'll see the same themes being drawn out. So let's just have a quick look at them, remind ourselves of what he was pointing to. So we know all about using resource-based addressing and resources through HTTP, although we do tend to focus on the obvious ones. It described hate OS, which is something that people love or hate. Talked about resource manipulation through the representation. So, a get and a put is and a post. For example, create, update, and then of course you've got HTTP delete and patch. Client server is fairly obvious in this day and age. Stateless is one that sometimes can be overlooked. insofar as what he's saying is any RESTful exchange should not be dependent on a previous RESTful exchange. So that you've got an independent, discrete dialogue. So if there are problems, then recommunicating the same payload is not an issue. He talked about the idea of code on demand, which was suggesting that you could pass a JavaScript code fragment through an API so that you could manipulate the front end dynamically. It's an interesting idea, but raises some real challenges around security and things like that. Layered is one that I've seen trip people up quite a few times. When we develop, we're working basically on our own little networks without restriction. But when we get into the big bad world in production, we've tended to forget that there are proxies and firewalls and content delivery networks and caches and all sorts of other internet and network infrastructure between us and the client. As a result, our interactions that can be quite big suddenly get broken because there'll be timeout constraints or payload constraints in the network. So it's always worth remembering about that. And if you're finding yourself creating APIs with big payloads, then maybe you're going to run into some challenges. And related to that is the use of cache. Caching can be our enemy and our friend. If you're running a solution that's doing things like stock management, stocks and shares, you really don't want caching getting in the way of your data flows, because the stocks and share prices are changing at a rapid rate and you don't want people seeing out-of-date data. But conversely, if you're dealing with product data, which doesn't change too quickly, then caching can be your friend, because it takes an awful lot of workload off your back-end system. The important thing is to remember this and use the HTTP features that allow us to tell the caching mechanisms what's good and what's bad in terms of its use. And of course, then the interaction should be self-describing. So what are the strengths of or pros, if you like, of REST as an API technology? Well, it's well understood, it's well supported. Just about any modern application development framework will support it for you. It's the most understood and most used these days in terms of public APIs. It's easy to cache the content if that's what you want to do, or not, as the case may be. Browsers and CDNs can do that. That's content delivery network, so you can push it near to the consumer. It's pretty self-describing, although you can abuse it and make it as opaque as you like. But it's also incredibly flexible. There are very little rules. There's no real opinion on its use. As a result, you can abuse it if you want, and create some real monsters in the forms of things like accepting SQL in a URI, which is a classic OWASP top 10 vulnerability. Very easy to formulate queries. Downside, that flexibility, as I say, can be a real challenge. It doesn't encourage any particular strategy for dealing with things like versioning. After all, the only constant in life is change. You can be too terse with data, and therefore you end up creating lots and lots of API calls for your client to get the information, or you can go the other way and be overly generous and flood the client with too much information, creating some real lag. Okay, so that's lightning quick look at REST. which we all know and love. So let's move on and explore a little bit more in terms of what GraphQL is and what it does and how it differs. So it was originally developed by Facebook, but it's now under the governance of an independent organization whose parent is actually the Linux Foundation. So it's nicely independent now of Facebook. And what they were trying to do is address this problem of being too terse or too generous with information, because what they were learning is that mobile platforms were the most common way of interacting with Facebook, and they were finding that if they were too terse, they were swamping their back end with so many queries. And if they were too generous with the information, the workload on the client device became a lot higher, and that affected user experience. So what they wanted was a framework by which the client can dictate how much data and what data is retrieved. Therefore, the right information is arrived on the first request, and it wasn't swamping if it was just a tiny little UI change or visualization that was required, but would get a lot more if it needed it. We saw, or we have seen, that the nature of this has meant that some really big players have picked it up and run with it. So it's not a Facebook-led thing by any stretch of the imagination anymore. GitHub have famously re-implemented their APIs to be using GraphQL, and Twitter, Yelp, all utilize the same sort of things. So it's based on using JSON. It leverages certain aspects of HTTP, but not to the same extent as you would with REST. But it does mean it's a paradigm that's fairly natural to anybody that's got some experience with RESTful interfaces. It does solve some of the common problems, though, or give you a framework in which solving common problems can be addressed around versioning and pagination of data requests, which is great because it means that you're reducing the chances of your APIs having to break to accommodate change. And the common misconception is, of course, that it's linked to graph databases. Not really. There's some underlying math theory that influence or informs both, but that's it. So let's have a look at a little example of a graphs-based solution. This is based on the Star Wars API, and I've abused it somewhat to make it a little bit more presentation friendly. But you'll see the principles here. I can define an interface called character, and within that I then define the attributes of character and what data types they are, and whether they're lists or the mandatory values. So the bang at the end of the declaration means it's a mandatory value. And I got an inheritance-based hierarchy, so if I could create a character, I can then use that as a foundation for specialization like droid, which is a particular type of character, and I can describe relationships of entities. As you can see, if you look at the droid description, it's got friends here, which is effectively a list of character, and it's optional. And you can see I've got another pairs in, which refers to episodes, and that's mandatory. Then what I do is I describe the operations that I'm going to support on that entity. So for example, I can query droid by passing an ID, and I'm going to get a droid back. A mutation is effectively the create, update, delete operations that can effectively change the data. And here I've got a mutation that says delete it, and here's the ID of the droid to delete. And I can add a droid and say, here's the new droid using the droid structure. That's great, but if I want to do a query, I can also not only describe which droid I want to get, which is what we see here, but I can describe which attributes that I want returned back to me. And this is where GraphQL really comes into its own, because now you can offer a fairly rich, information-rich structure. But if someone just wants the droid names because they want to present a list to the user, then that's all they need to ask for. But if they want more, they want to have rich information about a particular droid, then you can provide that as well, which makes it very powerful. So if I take this a little bit further, I can cross-link the relationships in the GraphQL request. In this example, I am saying, okay, take it from two structures that I want attributes from the episode in terms of what is the name of the film that the droid will appear in, and we can get GraphQL to do cross-resolution, if you like, on the queries or updates crossing entities. So we have this simple structure. So the moment you separate objects out, have this object relationship, you're not having to do multiple requests again. GraphQL sorts all of that out for you. So in the back end of a GraphQL setup, you have a GraphQL engine, which is typically implemented in Node. And then you have, as we saw, the idea of resolvers, which will effectively take the request and resolve it either by executing data manipulation or actually performing a query. And they can be spread over multiple backends. So as you can see in this little example, one is going to a RESTful endpoint, and another one's going directly to a database. But the consumer doesn't know nor care about that. All they're interested in is your graph schema. So let's look at the pros. The real key strength here is about getting the data that you need, and only that data. You can put the workload back into the back end in terms of sorting out your data, which is really valuable, particularly for mobile clients and things like that, where you haven't got huge amounts of compute power involved. The number of round trips, of course, therefore, because you're getting all of this done for you on the back end, is really reduced, which is great for user experience, particularly. But helps with IoT devices as well, because again, they're going to be lightweight, low compute capabilities. It's all JSON based, makes it still very easy for interaction and human readability. So if you're needing to figure out what's going on, it's very easy to poke in and look at the traffic and the interactions that are going on. Formulating the queries is incredibly straightforward. And it has opinions about how to deal with versioning, which makes the dealing with change very easy. You just have to follow a set of basic guidelines that are laid out in the standard. The downside is it doesn't use HTTP to its maximum. Everything is in the post structure, which means that you can't cache the payloads either. Building a very, very simple API to do a simple request, it takes a little bit more work. But the moment you get into more data relationships and asking for different types of data and manipulations, it gets a lot easier very quickly. Let's look at gRPC. So gRPC comes from our friends at Google. Most people assume the G means Google, but Google say that they change it. So I think at one point it was meant to mean ginormous and things like that. But you know, they play with it. But ultimately, it doesn't really matter. It's all about how it works. It is more of a true RPC framework. It's open source like GraphQL, It's been adopted big time by Netflix and Cisco. Part of that is to do with the nature of its compact efficiency in terms of network use, which we'll see in a minute. It is a lot more of a technical structure, as you can see, and it embodies more RPC concepts inside of it. It talks about services and messages. It's geared up to exploit HTTP2, unlike the others. It gives you standardization around error codes and error handling. It's payload and implementation agnostic, which means that you're not bound to a platform representation of text and things like that. But that was also a bit of a challenge, as you'll see. So because it's more of a technical one, the way it works is you actually end up building code, and obviously that means that we need to be able to take the definition of a gRPC interface and compile it into a particular language rather than just using a framework. And therefore, we're somewhat dependent on having the compiler. As I say, it uses HTTP2, but HTTP2's differences are at the lower levels of the stack to give us further performance gains in the data transfer. And again, it has support for versioning and compatibility, so we're less likely to run into the problems of change. And if you're familiar with Apache Avro, because you've been working with GraphQL or something like that, familiar with Kafka, then this will feel fairly familiar because there's some common ideas here. Let's have a look at a gRPC definition again. It uses a syntax called protobuf or proto, and there are two dominant versions, and there are some breaking changes between the two. So protobuf version 3 is well established. It's been around a while now, but as you can see, we've got here an example again based on the Star Wars API, where we have now a message which is an ID, and you can see the data types now are a lot more classic, very tightly bound structures. So we talk about integer, 32-bit integers and 64-bit integers and unsigned and signed, because one of the things that gRPC is trying to do is get a lot more efficiency into the network communication. You can see in here that there is a number after each of the declarations. That's reflecting the order in which the attribute needs to appear in the structure. Now that's important because what gRPC is going to do is say, okay, please tell me about the attributes that are fixed size and fixed number of occurrences first. So it can literally then pass through those values incredibly quickly just by using positional values. It then it accommodates things like strings and arrays through the word repeating, and you're encouraged to put that in a particular position. So for example here, we've got string first because it's a simpler structure, and then we're going to talk about character, which again references another structure, and we can have an array of character references, and then of course you got the droid structure, which builds upon the basics, and then you define the services. As you can see, get droid by ID. So then you just say it's an ID and what it returns. And then you can also handle requests for streams as well. So that's a bit more explicit here. The services are effectively pretty much operators on a class or functions on a class, and your payload definitions are effectively the attributes of your class. What we do now is we can give the Proto3 file some extra annotations, or you can provide it in the command line. And then we run the Proto compiler, and it generates our code. I'm classically a Java user, so I ran it to Java, and you can see it builds a whole load of operations and internal utilities, but ultimately we'll see things like this, where you can see get droid by ID, get character by ID, get characters by ID, and other operations that we might choose to define. We obviously therefore take that, compile that into our provider and consumer functionality, because what happens is this gets compacted down into a very compact structure, and has to be structured in a particular way, reflecting the ordering that we've defined, which gives us a lot of efficiency in then reading the data back. So how does that work? Well, in terms of benefits, compatibility can be solved, which effectively is back to versioning. It is incredibly efficient on the bandwidth use. Code generation is involved. So one of the things that that's always recommended, particularly if you're offering a public API, is the idea of offering an SDK. Well, actually, it's generating that for you. It does push us down the route of API first design, which is good because we're thinking about our structure and our sequencing rather than the implementation to start with. Compression, the language support. Downside is it is a binary payload, so poking in and looking at the messages in flight is difficult. It takes a lot more work. You effectively have to strip it out, have a little utility which will then unpack that message for you. You can't do simple queries onto the payload, but to traverse it or add new queries with an XSLT and things like that, or transform it. You've got some challenges around service meshes because they don't give, or not much support exists for service meshes around gRPC. Your server's now got to be HTTP2 compliant, whilst these days that's not so much of an issue. In a legacy landscape, that could be a bit of a headache. And of course, we've got the protobuf definition changes between versions 2 and 3, which can be a bit of a pain in the posterior. Right. So we've looked at all the different models. Let's have a look at some of the guidance and the recommendations that we've developed over time and share with people. So we've skipped some content. Right. But ultimately, what's important here is if there's a single API out there, then actually people will tolerate, in most cases, the constraints of the API. So if you're using gRPC and it's the only option available to them, people will use it. But if there are two APIs, then offering the same service, then people will err on the one that's most understandable. And actually, when it comes to, say, REST vs GraphQL, people will be a little bit more pragmatic and choose the one that they can understand the best to use. So ultimately, the technology takes second seat to being able to consume the API. But if the two are equal, then how do we move forwards? Well, I talked about needing to have a good API definition. That's what we think a good API publicly requires. And then internally, as you can see, we've faded out a number of the areas, but there's still fundamentally some key elements needed of a good API. So accepting if we had the comparable APIs with comparable supporting material, then what would the answer be? Okay, so one way to evaluate APIs would be to use the fielding definitions, and obviously it does bias the outcome to REST, but it's useful as a comparison and a reminder of the options and possibilities. So you can see the REST-based characteristics, come out as a yes on all of Fielding's criteria. GraphQL, some yes, some you can achieve but needs a little bit of work, and some just aren't achievable. And gRPC, is even lower in terms of its ability to match his criteria, but obviously it's a little bit biased. So we came up and approached it this way and said RESTful is good for public APIs. That lowest common denominator means that everybody can consume it. All right, but it does require an API provider a little bit more discipline in terms of trying to ensure that you're addressing some of those classic problems like the versioning, like change, and things like that. You can offer webhooks and features like that, which are very easy. The RESTful APIs are very easy to be leveraged through the use of enterprise service buses and technologies like that. So if you think they might be involved, then you can't go wrong with REST. When it comes to GraphQL, if you're dealing with a device at the other end, then it's great. It supports streaming. I didn't mention that, but both gRPC and GraphQL will support streaming. It's also very good for public APIs because it tends to encourage good documentation. It has some opinionation, which means that the common problems are things like pagination and versioning. You're imposed with dealing with those, and it's very, very readable, like a RESTful interface. And it's great for exposing large bodies of data sets. If you want to expose a data warehouse to consumers or data lakes, then fantastic. But don't think of it as a bulk data movement technology. It's just a query. It's primarily a query technology. It does allow you to do update, but it's great at that querying and allowing people to express the querying of data without resorting to trying to shove SQL into payloads. And then gRPC, great if you've got control of both ends of the data flow. So you are providing the client and providing the server side, because both the client and the server must be in line with those protobuf definitions. Whilst there's some versioning support, there are limitations. So if you don't have control of both ends, then you need to think long and hard about it. You can do that if you want to have control of both ends, but don't have control of the client application. One way of overcoming that is to provide it and offer it as an SDK only, and not talk about the actual core protobuf payloads. It is great for bandwidth sensitive environments because of that compression mechanisms. It supports the bidirectionality and streaming, and because it's compiled down as well into the code base with that manipulation to keep the data payloads down, it's great for IoT solutions because the footprint ends up being very, very compact. So the bottom line, there is no right tool for the job. It's about selecting the right one for what you're trying to do. In fact, if you look at Google, what they do with their APIs is typically they offer you a REST one, and behind that is a gRPC version of it as well. So you could use gRPC directly to most Google APIs. If you want to use REST, there's a REST layer on top of it. So they accept that both are needed. Certainly internally, Google favor gRPC and use gRPC because it gives them the optimization. When you're working at the hyperscale levels, a tiny little gain is a significant saving. So, gRPC is great for those internal use cases. And again, that comes back to that control of both endpoints. There is no silver bullet here, as I say. And it's worth equipping yourself or considering equipping yourself with more than just one. So for a lot of people, GraphQL may well be the second option to go down because it's the easiest transition. If you're working with Kafka, then maybe you do REST and gRPC because that's easy to provide a second option. But don't try and solve every problem with only one technology. We've seen that with SOA ESBs, where everybody tries to use them to beat every integration problem, and as a result, the tools have grown and grown, but also people have lost a bit of faith in them to an extent because they find certain problems are difficult to solve, and that's why using different tools for different problems is going to make your life easier. It does increase our requirement for knowledge, but there you go. And we're open for questions. I can't see anything in the question channel at this stage, so I will give it a moment, just see if anybody posts.
I guess we have one question, Phil. We have one question in the chat
Okay.
box. I'm just going to read it to you then. So it says, would you use an API to move data from one Oracle database to another in the same data center? So yeah, what would you say is the limit on the size of data moved in an API? For example, would you move 500 GB of data from one database to another each day using an API?
In the high volume data movements APIs, I wouldn't recommend, well, at least an HTTP based API like the technologies we've just looked at. I would look at different solutions, but that doesn't stop you from applying some API based thinking in terms of trying to establish lower coupling between the two databases. So if you were connecting, let's say, an e-business suite and a Seawall, then I would try and avoid trying to do the data migration by just taking a chunk of one of their core tables. I would try and create a decoupled view, a simplified view through perhaps views on the database, and then use that to sync. So if there's a change in your Siebel or eBiz, then you can obscure that in the integration, which is effectively one of the arguments for using APIs, is that loose coupling framework. But as I say, said from the outset, we still use databases as an API at the most abstract level, because what we do is we define a database schema that's effectively common to the provider and the consumers, and work that way. So the roundabout answer is based on that particular scenario, I would probably err to using database technologies rather than resorting to APIs.
Cool.
Okay. As you said at the opening, if there are questions that follow, then please do follow up, and we'll try and get back and answer them through the various channels. I'm also available on social media, so don't hesitate to reach out more directly, and I can talk to you that way as well.
Yep. Okay, cool. So if we don't have any other question, thank you, Phil, for sharing your knowledge to everyone. And also for all the attendees, thank you for attending this session. And yes, we still have 2 more days until the this conference is going to end. So yeah, you still have 2 more days to register to all the other sessions, and enjoy the rest of the day. Thank
Lovely.
you.
Thanks very much.